Following our plan for this application, it's time to make the next steps, which are converting the IP address to binary, getting the network and broadcast addresses, and printing the results. First, following the exact same steps as we did with the subnet mask, we have to convert the IP address provided by the user to binary ones and zeros. I'm not going to explain this procedure again, since it is almost identical. Here we have an example of converting 192.168.2.100 to binary. So this would be the binary string resulted from these operations right here. The thing we should focus on is obtaining the network and broadcast addresses for the IP and subnet mask provided by the user. First, to find out the network address, you should match the IP address in binary with the subnet mask in binary, and identify which bits of the IP address overlap with the bits in the subnet mask whose value is 1. After this matching is done, the rest of the IP address should be filled with all zeros. In Python, we can do this by slicing the IP address in binary from the beginning all the way to, but not including, the index given by the number of ones in the subnet mask. So if we have a subnet mask of /24, then the IP address will be sliced from index 0 up to, but not including, index 24. This means from the first bit up to the 23rd bit, so actually the first 24 bits in the IP address. But we're not done. As I said, to get the network address, you must also fill the rest of the IP address with all zeros. That's why you should concatenate the IP slice we did right here with as many zeros as you have in the subnet mask. So I used string multiplying to do this using the asterisk. I think I could have used the zfill method here as well, zfill of 32 to be more precise. But this works too, so I'll leave it as it is. Next, I applied the same procedure for the broadcast address, only this time we should fill the IP address in binary with binary ones. Now let's uncomment these print statements and see the results. So let me uncomment this one and this one. Let's save it. And let's run the application. Okay, and this is the subnet mask. Okay, great, just what we wanted. This is the network address in binary, and this will be the broadcast address in binary. Now, to convert those binary strings into readable IP addresses, we should split each string in groups of 8 bits in order to get the octets. Starting with the network address, we can simply iterate over the string using the range function and using a step of 8. To make this clear, let's go to the Python interpreter and see an example. So, Python, let's say range starting from 0 up to 32 using a step of 8. So this returns every 8th element between 0 and 32. So for each index in the list returned by the range function, we are going to slice the binary network address, this one over here, starting from that index, in our case it is called octet, up to but not including that index plus 8, meaning indexes 0 through 7. Then we make a slice from index 8 up to but not including index 16, and so on until the end of the binary string, and then store each slice into a variable called netIPOctet. Finally, we are appending each slice to the empty list we created above the for loop, so this one over here. And I think now it's time to see this list. So let me uncomment this print statement. Let me comment the ones before. And I think I have another one. Okay. So let's see the netIP octets list. Let's run the application. Sorry. Okay. 1.1.1.1. The subnet mask. Okay, great. This is what we wanted. We actually sliced this IP address, this network IP address we just got earlier, into chunks of 8 bits. Finally, it's time to convert the octets from binary back to decimal using the in function for converting from base 2 to base 10. And then the str function, the string function, to convert these new values to strings, because in the end we want to join them into a single string. So this for loop iterates over the list we just got earlier, makes the conversions, and appends them to a new list, an empty list that we created up here. Now let's see the list again after the conversion to decimal has been completed. So let me uncomment this and run the application one more time. Okay, much better. So you see that these binary octets right here have been converted to decimal and then to a string format using this for loop I just talked about. Now the last thing to do is join those elements together to get the network address. So let's see how can we do this. Of course, using the join method, using the dot as a separator between the octets and the variable holding the list of octets inside the join method. So let's go ahead and uncomment this print statement as well and run the application one more time. Sorry. Okay, so finally we went from having a list of binary octets to a valid network address in decimal. Okay, cool. Now let me comment these print statements back to clear the output when we are going to run the application again. Now the same procedure is applied for the broadcast address as well. I won't explain it. I'll let you analyze it and also test it using the print statements. The last thing we should do in this lecture, according to our plan, is print all these values to the user using print statements, format operators, and of course the variables we want to see. So these are the print statements right here. I use the string format operator in each of them and the variable we need to print out in each case. So let's do a small test, although we've seen those variables printed out a couple of times by now. Let me save the application and run it. Okay, great. Now we have a functional subnet calculator. We can see the network address, the broadcast address, the number of valid hosts per subnet, the wildcard mask, and finally the number of mask bits. All these values being calculated based on the IP address and subnet mask entered by the user.